We'll proceed in tedious calculus problems. So tedious calculus problems, we are in a phase to calculate internal resistance of capacitor. Indeed, we have calculated internal resistance of capacitor. I mean resistance of the capacitor. There is a bad word called internal resistance of the capacitor. Resistance of the capacitor. Or rather, someone would say the resistance model of the capacitor. What we have talked till now is that if I have a capacitor and okay, we are using calculus, okay, to calculate the kind of net calculation, we are using calculus. That is the concept that we are pursuing. Okay, so for the capacitor, like this is a capacitor. This is a capacitor. This is 330 microfarad capacitor. And here on this side, there is a resistor that is connected to the capacitor. Resistor connected to the capacitor, and this is the capacitor. If this hole is connected to a battery, this is the battery, and if this is hole is connected to a battery, this is called charging circuit. And as we have mentioned, that in charging circuit, if I charge the capacitor and resistor, they are connected in a series, and then all together they are connected to a battery. To a battery, there is nothing called capacitance, inductance, resistance, or something like that. To a battery is always, there is only one kind of battery, that is called DC battery. AC is nothing but DC only, where the battery is changing its polarity. Okay, that's it. Otherwise, and the battery, the voltage is from zero, it is going maximum, coming back to zero, changing its polarity, and then going to maximum, coming back to zero. Again, changing its polarity means current is flowing forward, backward, backward. And this is how it is propagating. This is called alternate current, and DC, where the battery voltage is constant, there is no change in the polarity, and current is flowing at one certain level. But anyway, that certain level is broken by this capacitor. In the sense that if I have a capacitor and resistor that is connected to a battery, then battery never sees it is an inductor, capacitor, whatever. For battery, there is a load, resistance load is connected to the battery. If load resistance is R and battery voltage is Vs, then current will flow called Vs by R. That's it. What is the wattage of the energy that is flowing from the battery? Current into voltage is the wattage of the battery. Wattage means energy per hour that is flowing from the battery. If 50 joule of energy, net energy that is coming out of the battery is 50 joule, in 1 hour that energy is taken out from the battery, then it is 15 watt hour is the that much is the power that gone from the battery. Okay, so that is the scenario of the battery rating. Anyway, the idea is that if there is a battery and there is a load connected to the battery, and then current is coming out because it is seeing the load as a resistance, then there will be a resistance model of the capacitor. And so there is a resistance, that is R, capital R is connected to another resistance called X. This is what we have seen now. So I have a battery, and this battery positive side is connected to resistor, and then resistor is connected to positive side of the capacitor, and negative side of the capacitor is connected to the negative side of the battery. This is the circuit called RC circuit. Battery positive side is connected to resistor, and other side of the resistor is connected to positive side of the capacitor, and negative side of the capacitor is connected to the negative side of the battery. So this is typically called RC circuit. If this is RC circuit, if this is the RC circuit, then what is the resistance that is offered by the capacitor, because battery is seeing a resistance block. In that sense, if there is a resistance of the resistor is capital R and resistance of the capacitor is X, then any moment the net resistance of this block RC block is R plus X. But problem is X is changing. X is not constant, whereas R is constant, whatever it is. Whatever is the resistance at any moment, that much is the voltage source, battery voltage source is Vs. Vs by R plus X is the amount of the current that will flow any moment. That is the scenario. Current that is flowing any moment that we have calculated it, and current flowing any moment in the RC circuit is I0 e to the power minus t by RC. That is calculated. If that is calculated, then I0, that is the beginning current. At the beginning current, we consider that capacitor is short circuited. In that sense, beginning current is Vs by R. That is the beginning current. Anyway, I0 e to the power minus t by RC is the current equal to voltage source Vs by voltage source Vs by R plus X. That is the concept. Now, if that is the case, then R plus X equal to Vs by I0 e to the power minus t by RC. I0 is Vs by R. Vs gone, R will come up. Now we have R plus X. In that sense, X equal to R minus R e to the power minus t by RC. R, and in bracket 1 minus e to the power minus t by RC. This is the resistance model of a capacitor. If capacitor is connected to a resistor and whole this series is connected across a battery, what is the variable resistance that is showed by the capacitor at any moment of the time t? Then that variable resistance is X equal to capital R, and in bracket 1 minus e to the power minus t by RC. When t is 0, then at the beginning the resistance that is showed by the capacitor is 0. When t is infinite, then infinite means e to the power minus t by RC. If t is infinite, that term will reduce to 0. If that, I believe so, or 1 minus e to the power minus t by RC. Okay, if okay, I believe it is not correct. Means if time is infinite, then resistance showed by here should be infinite. So I am going to change. So we will see it again. I current at any moment equal to voltage by R plus X. Current at any moment equal to I0 e to the power minus t by RC. R plus X equal to Vs by I0 e to the power minus t by RC. There we made the mistake. So Vs by I0 e to the power t by RC. Now I0 is the beginning current, that is Vs by R. Now it is R e to the power t by RC, not minus t by RC. Here R plus X equal to R 1 minus e to the power t by RC. That is the correct formula. So the resistance that is showed by the capacitor at any moment, this is called resistor model of the capacitor. Now that is the X equal to capital R in braces 1 minus e to the power t by RC. If t is 0, then full term will become 0. At the beginning, there is no resistance shown by the capacitor. When time is infinite, then 1 minus infinite means it is infinite. More or less, the resistance shown by the capacitor is infinite. Okay, when time is infinite, means current would not flow. When resistance become infinite at the battery volt source, then current would not flow. This is called resistance model of a capacitor. This is new thing that we are bringing, but because we know that DC battery source does not know about the phasor difference and this and that, nothing. It knows only what is the resistance load is at the battery, that much current would flow. Okay, for capacitor kind of electronic component, capacitor kind of electronic component, This is also known as variable resistance component or energy storage component. The resistor does not store any energy, it dissipates energy, whereas capacitor will store energy. But we can have resistance model here, where resistance will start from zero in charging circuit and then it will go to infinite. In that sense, it will block the flow of the current completely when it is fully charged. So it is a variable resistance device or it is an energy storage device, same as the inductor. Okay, what about in discharging circuit? When it is completely charged, okay, when it is completely charged, I believe I had showed. So I'll charge it again. So we will see the kind of discharging circuit. So if I charge it, okay, I don't know how much it is charged. Okay, I have charged it and I'll discharge it through this LED. This is the LED. This will blink for some at the beginning, then it will fade quickly because this capacitor is not very high valued capacitor. So it will blink a little bit and it will fade. Okay, so it glue, then it dim. Means battery go at this. When I connect this, when it is completely charged and it is registered, it is completely charged and then it is connected through a resistor. And then I close it, then I close it. Now this is the capacitor and this is the resistor. Capacitor is completely charged and it is behaving like a battery. At that sense, we this is not the same as that capacitor is placed in a charging circuit. When capacitor is placed in a charging circuit, at that moment it is showing variable resistance that is 0 to infinite. But when capacitor is placed in a discharging circuit, then it does not matter because it is behaving like a battery. Battery which has a charge storage and charge is flowing in a mode of current and current is dissipated by the resistor. Okay, at the beginning, how much charge is flowing? That is the net voltage at the battery and net voltage at the resistor. So, in any moment, if V is the voltage across the resistor, that is same as Q by C. What is the charge at any moment across the capacitor by C? That is the voltage. That is I into R. If someone differentiate it, 1 by C dq by dt equal to di by dt into R. Dq by dt is I. Okay, dq by dt is minus I because dq by dt is negative. It is decreasing. So in that sense, minus I by C equal to di by dt into R minus 1 by RC dt equal to di by I. In that sense, I equal to e to the power minus t by RC. This is the current that is flowing at the beginning. Okay, no, I'm sorry. That is di by I equal to minus dt by RC, di by I. Di by I, if I integrate from the beginning current, so beginning when it is connected across the resistor, the flood of current will flow. And in that sense, then it will be beginning current. Beginning current is if voltage across this capacitor is Vs, that is the voltage of the battery at the beginning. Then Vs, okay, in that sense, we are kind of calculating the net current. So beginning current will be Vs by R. R is the resistor of the resistance. So Vs by R, I 0. So integrating current will be I 0 to I. Anyway, it will become I equal to I0 e to the power minus t by RC. That is the current equation that we are seeing. Now, what about the internal resistance of this capacitor? That will not come into the picture. In a way, that capacitor is behaving like a battery. But idea is that why I have given many times why we have taken dq by dt, not q by t. Anywhere you see that the current is q by t. Per unit time, how much is the change in the charge. Division means change in the numerator per unit change in the denominator. That is called division. But here, the change in the numerator, change in the charge per unit time is dependent upon time. Every time the change in charge that is seen per unit time is different. At the beginning, lot of current will flow through the resistor when capacitor is fully charged. At that time, dq by dt is high. When it is moving toward the time, then dq by dt will be slow. If charge is less, then change in the charge per unit time is less. If charge is high, then per unit the change in the charge per unit time is high. So change in charge per unit time is dependent upon the time, and it is negative direction in a sense. If time is growing, then dq is less per unit time. So dq by dt is minus I. Anyway, so that's why we went for calculus, because q by t, if q by t is constant per unit, per how much charge is changing per unit change in the time, if it is constant, we don't need calculus. If q by t is not constant, it is variable, and numerator is dependent upon denominator. Many times we have said x square by x is x. Okay, but whenever result comes as algebra, be careful now. Okay, 4x by x is 4, no problem. Anyone can go through normal division. Calculus is not required. 4x by 4 means how much numerator, that is 4x, is changing when there is one unit change in denominator, that is x, that is 4. If someone draw 4x by 4 graph, then at any x it will be 4x. Okay, x equal to 1, then it will be 4. When x equal to 10, it will be 40. Okay, so 40 by 10 is 4. 4 by 1 is 4. So division is constant. In that sense, the division graph will be a constant line against x. So if division is constant, then someone can see, if someone see between 9 to 10, time is 9 to 10, 1 second of the time, how much change in the numerator I am saying 4. Between 2 to 3, how much change in numerator I am saying, that is 4, 4x by x. But if it is x square by x, where numerator is dependent upon denominator, in that sense, if x is 1, then 1 unit of change in x, if someone is saying change in the numerator, that is x square, it will be something different. If someone is seeing when x equal to 9 and 10, once 1 unit of difference is there, then x square, the difference in that y factor will be different. In that sense, y by x or x square by x, that become x, that is completely false. Then it is dx squared by dx, that is the division. That will come as 2x. Similarly here, charge by time, charge, how much charge is changing per unit change in the time. This is what we are discussing. If that change in the charge per unit of the time is dependent upon the time, when time is 1, change in the charge is different per unit change in the time. When time is 5, per unit change in the time brings another change in the charge. And when 10 equal to 50, there change in 1 unit change in time brings another unit of change in the charge. It is not constant. Then dq by dt. Someone has to leave the division fundamental blindly, someone has to come to differentiation. Anyway, that's why I did dq by dt. Anyway, current equal to I0 e to the power minus t by RC is the net formula in the discharging circuit. This discharging circuit resistance of the capacitor does not make much sense, because we don't take resistance of a battery. Battery resistance typically it is very less. So we don't take internal resistance of the battery. So in discharging circuit, we don't take internal resistance of a capacitor, because capacitor starts behaving like a battery source. But problem with the difference between battery and capacitor is battery voltage is constant, whereas capacitor battery, it slowly it starts shrinking. The way it starts, releasing the current. That is the fundamental. But anyway, people can calculate, consider the internal resistance of the capacitor is X. Then net resistance in this discharging circuit is R plus X. So current, okay, so current that will flow at any moment is I. Then I into R plus X is the net voltage at any moment. I plus into R plus X equal to, so net voltage at any moment, net voltage at any moment is, is, is how much? I believe it is net voltage at any moment is X by Q by C. Now di by dt, di by dt, R plus X equal to I by C. Okay, now someone is free to calculate the equation of X here, di by dt by I, di by dt by I. T will go on that side and then it will become T by T by T by C R plus X di by I. Okay, it will be negative because dq by dt will be minus, dq by dt will be minus I. Now someone settle down at that moment, then it become I equal to I0 e to the power minus t by R plus X. Okay, now someone can calculate what is R plus X. So it will become ln I by I0. ln I by I0 equal to T by C into R plus X. Okay, C into R plus X, C into R plus X or R plus X equal to time by current I, time by ln I by I0, I0 is the beginning current, time by ln I by I0 into C, X equal to R minus time by ln I by I0 into C. That is the internal resistance of the capacitor. More specifically, people can calculate in coarse manner also. People are free to do whatever they want. People can calculate in coarse manner also. I into R plus X is the net voltage. Then it is net voltage, that is X into I or whatever it is. Then X equal to whatever. Someone can calculate. I believe we calculated through some way. That came as internal resistance is same as external resistance. But this is the exact formula of the internal resistance while coming in the discharging circuit. That is T by C, T by C in denominator, C into ln I by I0. R I0 equal to R plus S, X equal to R minus T by C into ln I by I0. When T is infinite, then I is 0. Anyway, it will become R minus Rx, whatever it comes. This is how it is. But internal resistance, generally people, they do not calculate for the battery source. It is considered as, means this capacitor is a kind of a mind-blowing device. Mind-blowing device because in charging circuit it is behaving like a variable resistance. In discharging circuit, this calculation of the internal resistance does not come into the picture at all. But this is how it is. I believe it is again variable. R minus T by R minus T by C into ln I by I0. Okay, ln by I0. At the beginning, I equal to I0. ln of 1, I believe it will be 0. Something like that. Then it will become like a by 0 to something times 0. It is not defined at the beginning. Midway, we can calculate at any time what it would be. Then ln I will be some small value into capacitance and into the time. It will be less than, but as time is growing, this internal resistance will become lesser and lesser because R minus T by something. So it will become slowly, it will become lesser and lesser. At the beginning, it will show more resistance. This is what I think. Whatever it is non calculable, not required. Calculating internal resistance of capacitor, any battery source is not required when it is behaving like a battery. Anyway, What is next in the agenda? So next agenda, now if someone watch carefully, what is the voltage current relationship in the charging circuit? If I have a charging circuit, in the sense, charging circuit means this is a battery source. This is a battery source, this is positive, this is negative, and this is connected across a RC circuit. This is resistor, this is capacitor, and it is connected across the battery. Now, at the beginning, there is a flood of current. Now, see the voltage across capacitor and current relationship. At the beginning, there is no voltage across the capacitor because we have calculated the resistance of the capacitor in the charging circuit, resistance model. I can remove this capacitor by a variable resistance X that is equal to R, that is the resistance of this resistor that is connected in series, R, and in bracket 1 minus e to the power t by RC. That is the equation. When t equal to 0, then x is 0. When t is infinite, then x is more or less, it is infinite. Anyway, if that is the scenario, then this is the resistance model of a capacitor. Okay, now if someone watch it carefully, if someone is watching it carefully, now see now consider this capacitor is a resistor. This is capital R resistor and it is connecting to another resistor called X. X. There is no capacitor here. X. Okay, at the beginning X is 0 and the way time is growing, X is growing. The way time is growing, the X is growing. This is what the concept is. Now, in that sense, the at the beginning, the voltage drop across this X, since X is 0, the voltage drop across the capacitor is 0. After some time, voltage drop across the capacitor will start growing because X is growing. In that sense, current is decreasing. At one moment, voltage across the capacitor will be maximum and current will be 0. Okay, now can one guess the relationship between the voltage across the capacitor and current that is passing through the capacitor? Anyone would say it looks like they have anti-relationship. They have anti-relationship. When current is flowing maximum through the capacitor, then voltage is 0. When current is 0, then voltage is maximum. If someone take out the kind of I mean someone flip the polarity of the battery. Consider someone flip the polarity of the battery. Earlier, this was positive, this was negative, and positive was connected to a resistor, and then it was connected to a capacitor. So, the current passing through the capacitor was 0 when voltage was maximum. It was maximum when voltage was 0. If someone flip it, then current will start flowing in reverse direction. In that will start flowing in a reverse direction. But beginning current will be 0 and voltage is high. Voltage will start dropping and one time will come when voltage across the capacitor will be 0 and maximum current will flow in other direction. Means voltage and current are always anti to each other. Now consider there is what is the algebraic equation they are anti to each other. Can someone prove it? This is my heart. This is my sentiments because I am telling like this that current and voltage are anti to each other. Is there any waveform that is anti to each other? There is a cos x and sin x. They are really anti to each other. If sine is 0, if I am taking time as a radian, that is 0, pi by 2, pi, 3 pi by 2, 2 pi plus pi by 2 like that. When time is 0, then if I take sine wave, then value is 0, whereas cos wave has value as maximum. When time is pi by 2, then sine is maximum where cos is 0. When time is pi, then sine is 0 when cos is minus 1, maximum in other direction. When time is 3 pi by 2, pi, 3 pi by 2, then sine is minus 1, that is maximum, cos is 0. They are, this is called phase difference. Means sine and cos wave, they have phase difference of 90 degrees. This is very important thing in capacitor. Capacitor behavior is something that is should be experimented more. We brought concept of external resistance model of the capacitor in charging circuit. Anyway, in this charging circuit, the resistance model is not required because it starts behaving like a battery. So it is all right. What about the phase phase fundamental? Phase fundamental means the current and voltage, they are anti to each other. If one is cos, then one is sine. The way, this is what I feel. So this is my sentiment. Because when current is growing, voltage is, when current is maximum, voltage is zero. When voltage is maximum, current is zero. Every time it is like that. You flip the polarity or do whatever it is of the charging circuit, I am saying. Okay, then it looks like if voltage source is sin x, then current flowing is cos x. If voltage source is cos x, then current flowing is sin x. Can you prove it? I understand that this is your sentiment, this is your personal sentiment. Can you prove it? Okay, voltage across capacitor is charged by capacitor, that is equal to the current, that is equal, okay,